In this film, we're going to discuss how to print out all the anagrams of a word. That is, every possible ordering of the letters of the word. In this case, it isn't immediately apparent how to solve this with loops, but as we talk through solving this problem recursively, you'll see that it leads to a short and elegant solution. The first rule of recursion states, I can solve at least one small problem. This forms the base case. Thinking about the anagram problem, the simplest word to print all of the anagrams for would be one letter long. The word itself is the one solution. So, the base case of our recursion will be when the length of the word is 1. The second rule of recursion is, if I can solve a slightly smaller problem, I can solve this one. Consider the word teal. In this case, we'd want to print all of the anagrams of a word of length 4. How could we make the problem smaller? Well, we could remove a letter, leaving eel. If we were able to get all of the anagrams for eel, we could put a T on the front and have a bunch of anagrams for teal. That's not enough, though, as we miss anagrams like late or leet. But what if we did the same thing removing L from the word? We could then put L on the front of all the anagrams of T. That gets us halfway there. If we repeat this for every letter in the word, we can make the anagrams for a 4-letter word by prepending a letter to the solution of all the anagrams for 4 different 3-letter words. Recursion will take care of the rest. Each 3-letter word gets anagrams by putting a letter on the front of anagrams of 2-letter words. Each 2-letter word gets anagrams by putting a letter on the front of anagrams of 1-letter words. Each 1-letter word is its only anagram, so the process will stop. Now let's talk about how to translate this into code. Since we decided to add letters to the beginning, we'll have a prefix parameter in addition to a parameter for the word. The base case, the one small problem we can solve directly, is when the word is 1 letter long. In this case, we print out the prefix and the word. The recursive case is more complex. In the else, we know that the word is at least 2 letters long. So we add a recursive call, removing the first letter from the word. So if the word is n letters long, we'll print out all of the anagrams for the word with the last n-1 characters, with the first letter as a prefix, plus any prefix that we already had. We do the same thing for the last letter of the word. We add the last letter to the prefix and do a recursive call with the first n-1 characters of word. In the middle, we loop I through the middle letters, from 1 to word length -2. In each case, we add that letter to the prefix and remove it from the word. We remove it from the word by concatenating the substring of all letters before the ith letter with the substring of all letters from I+1 to the end of the string. Now we're done. We have a fairly compact method that prints out all of the anagrams of a word. To hide prefix from the user, we can add a small method which calls this one, initializing prefix to the empty string. You can download a complete Java program containing these methods from java.martincarlisle.com.